What? No, your glasses are up there. That's where they went. Hello. I'm Dan Schultz from the Internet Archive, and so I want to talk a little bit about what we're doing at the archive around artificial intelligence and applying it to our TV corpus. So I'm going to dive in first. I don't know if everybody here knows about the archive, and specifically I don't know if people know about the TV archive. I want to talk about some of the data that we're generating and that we actually have, as well as some of the data that's available in TV more generally. So stuff that we want to be tapping into that we're not yet, and that I think everybody in this room probably is touching on different pieces. But as the archive, we want to kind of serve as a hub. Talk a little bit about the experimentation that we're doing to tap into those things, and then a bit of the vision for what we want to be building going forward. So, the archive. Who here has heard of the Internet Archive? Okay. And I'm just curious, who here has heard of the TV archive? All right, this is a much higher ratio, as expected, than usual. Usually it's like 2 hands raised for the TV archive. So the Internet Archive, for those who don't know, it's based in San Francisco. Started around a little over 20 years ago. And their mission is to archive everything digital, everything on the internet, also some physical stuff. But they have petabytes and petabytes of data. We also, though, have a thing called the TV News Archive specifically. So in addition to taking pictures of snapshots of the web and allowing you to see, the old versions of the New York Times, for instance, or whatever URL you type, we are recording television. So we're recording cable news. We're recording a couple local news stations in Philadelphia. We're recording C-SPAN because people love to watch C-SPAN. And we store all that. So it's been happening since around 2009, and it's continuing to happen. There are a couple ebbs and flows of random cities around the country, and I'll talk a little bit about why we have that. But the consistent stuff is really the cable news and sort of some local affiliates. There's a Python API to access this stuff. We don't let you necessarily the average person can't download the video because we are not a public DVR. We are a library. But we store MP4s, MP3s, raw video, and we also have this cool way of associating metadata to subsets of video. So we sort of have this clip-based metadata storage capability. So we can say, hey, this clip of TV was fact-checked by PolitiFact. This clip of TV is a political ad. This clip is Nancy Pelosi talking. And that is kind of what I think this talk is going to be about, making that clip functionality more robust. Also, we have, the rest of the internet. So I won't walk through the TV Archives interface, but check it out. So it's archive.org/details/TV, and you can search captions. So we store the video, the raw video files, and the closed captions, and we utilize closed captions to make it so people, researchers, journalists, or anybody can search the corpus in terms of words. And then you can watch small clips, so about 1-minute clips. You can watch the next 1-minute clip if you want. So you can really basically watch whatever it is you're trying to explore, and then you can embed that journalists use this to embed in their articles about a given topic or maybe about the debates, things like that. So I'm going to take a step away from the archive and talk more generally around video, but more specifically television video and the kinds of data that we want to be able to pull from this. So what do you have in a program? Let's say you record Morning Joe. You have an hour-long program. What do you get? You have the video, you have the audio, you have captions, right? This is stuff we all probably would come up to think about. But you also have, when we're dealing with TV, a whole bunch of other stuff. You have information about the program itself. You have the context of when it was aired. So it's not YouTube. It's not that they've been there for 4 years and being replayed. It's something that's being aired at a moment in time, at a moment in history. And then you also have information about the audience, who's watching that, what are their demographics. Within each of these categories of data, and not all of this data is easy to grab, but within each category of data you have signals that you can pull from it. So for video, we can look at faces. We can look for specific objects. What kinds of effects are being used, special effects, lighting effects, etc., that might be meaningful for something. What words are being displayed. For audio, you have things like pitch, frequency, what language is being used, what are the words being said, how loud are things, how soft are things, what music is being played, is there a genre to the music, and are there any sound effects. Captions, you have the actual text, and you have the times that the text are being aired. Now when we get to program, this is where I think things become maybe a little more amorphous, but for program, we know what time a program was aired, so again, what is the moment in history. We know the themes that a program tends to cover, because programs are repeat events, so we know that this is something that covers the news, maybe this is something with a certain political slant, maybe they focus on world affairs, maybe they focus on local affairs. You have hosts, which might have history across other programs. And then you have the actual descriptions of the programs as provided by the network. With context, you have related programming. So, hey, this is aired at 9 o'clock. What else was aired at 9 o'clock? What other things are being said in other news programs? What isn't being said in this one? You know what's happening in the world because you can scrape things like websites and see what the news of the day was. So likewise, you have context around what is or isn't being covered. And then you have meta-narratives, which kind of speaks to this, hey, what is this moment in history that this video fits into? And then overall, the way on the audience side, social media, what are people saying in response in real time or over time? What are the demographics of the people that are viewing something? And what are the social networks of those people that are viewing it? And sort of what types of relationships are we seeing? So, this is not necessarily comprehensive. It's intended to sort of be a smattering, but the reason I'm showing it to you is because this is the data that we want to be able to. When you think of video as a black box, this is the stuff contained in that black box up here for generic video, and then if you add in television, this joins the black box. And so this is all stuff that can be extracted. It's stuff that can be used by researchers or storytellers. And it's stuff that can empower use cases. And whatever it is you're trying to build, these are the different pieces that we want to be able to, at the archive, as a central place, help extract. This is just a list of some examples of techniques that you can apply to those signals to make better meaning from it. So if you know there's text in a video, you can extract that text. If you have pictures of people's faces, you can first off do facial recognition, but you can also eventually do speaker identification. Who is actually talking right now? If we could automate that, that'd be great. You can also incorporate audio into that. Audio and video fingerprinting, which is using the frequencies to find other copies of the exact same audio that have been broadcast in other times. That's really useful for things like debates. When debates get covered the next day, knowing what moments were covered or not. Finding copies of commercials or political ads. And that's all foreshadowing, by the way. Automated speech recognition is how can we automatically extract more accurate transcripts, because a lot of broadcast television, we have the luxury of closed captioning because by law the broadcasters have to provide it. But a lot of those captions are actually very low quality, so can we use some of those signals to improve the captions? Speaker diarization, which is being able to break up who is talking. If there are 3 people in a room having a conversation, knowing that this person said this and that, but not that. Claim detection. Different patterns of speech. It's possible to know when somebody is making a statement versus asking a question or making an exclamation. So if I can automatically know who's talking and that they have said they've made a statement that can be evaluated for truth, that is very useful potentially for fact checkers, for instance, to know what claims are being made on a given day. And then topic modeling, what are people talking about, and sentiment analysis, what's their general attitude. again, this is just a set of examples, but when you have a huge corpus of television, these are the kinds of things that if you can crack any of these nuts, it can expand into 10 years of television and then television going forward. So I want to talk a little bit about some of the experimentation that we have been doing at the archive. The archive is a library, so we don't necessarily want to be the ones responsible for doing the experimentation. In general, we want to be enabling the experimentation. That said, we have been doing some. So in 2014, we did political ad analysis in Philadelphia. So very small, very, very human done, basically looking at 4 channels worth of television during an election year and finding all copies of political ads by hand and tagging each political ad to say, this is, for this Democratic candidate, the ad is about unions and it was funded by this, pro-union super PAC. In 2016, for the presidential election, specifically for the primaries, we wanted to really expand that across the country. No longer can that be manual. So that's kind of where I dove in, used an open source audio fingerprinting tool, which does, again, frequency analysis, summarizing tiny segments to convert sound into a hash, and convert the sound into something that's easy to search against. So we did that audio fingerprinting, fingerprinted each political ad that we found, and then found all other copies of that ad. And so we searched over 26 different markets. You can see that's the kind of the final map of what our experiment was, and we found 375,000 or so political ads aired in 2016. Now, that is not the real number is much higher than that, because we didn't track everything, and of course there are misses and things like that. But for a given ad, we now have this data, which we released for journalists to use, so we could know that a given ad, I didn't show the ad for space, but there's an ad up here, and you can see, all right, the first airing was October 28th, and it aired all the way up until the election, right? And you can see which areas were targeted consistently, where it came first. You can also, for a given area, see what are the ads that are being targeted at that area. For a given sponsor, what are all of the different ads that a given sponsor paid for, and in what areas, and what are the patterns there? So the point is, by utilizing some, call it artificial intelligence, call it algorithmic, but by utilizing sort of taking advantage of these signals, we're able to extract data that can be used for impactful narratives that are really relevant. You can learn more about this particular one, bit.ly/worst-DVR. Talks a little bit about the technology behind it, talks a little bit about what we did. It's called the Duplatron. That's what it looks like. The latest thing, which is just launched today, which is called Face-O-Matic, because we like stupid names. No, they're good names. So this is using facial recognition. So there was an algorithm released, I think, in 2015, a paper published called FaceNet. I'm pretty sure it's what the Googles and the Facebooks of the world use. It's really efficient facial recognition, facial identification, not just recognition, facial identification. You train a model on a face. You take 50 pictures of Nancy Pelosi and train it. This thing finds Nancy Pelosi, like 98% accuracy. So we have experimented running that algorithm, training it on 5 different politicians: Mitch McConnell, Nancy Pelosi, Paul Ryan, Chuck Schumer, and Donald Trump. And we're running it constantly on our video as we're recording it. So we're recording in real time. It takes probably 4 hours to convert the video stream into MP4s and all the different outputs we want. But once that's done, we run it through this algorithm, and the algorithm takes not very much time at all. We're working. There are open source implementations of the algorithm. We're not using them right now. I hope to move over to one. Right now, we're working with a company called Matroid, which is a startup that does artificial intelligence. I posted a link to in the HyperAudio Slack to Face-O-Matic. You can actually see this stuff as it's streaming in, and so it will show you for this program. Mitch McConnell was detected for 7 seconds. Donald Trump was detected for minutes of time. Slack is not necessarily a great stream for structured data, but this is our first. This is a prototype, and so we really want to know. I specifically really want to know what do you want to use this for? What does this data trigger in your mind as things that are interesting? And what format would you like it in? Okay. So the other thing we're doing is Chiron extraction, which Tracy, Jake with my colleague, is not here today. I think she's talking about that tomorrow morning. Great. So, extracting the lower thirds and comparing, hey, Fox News is highlighting this in their lower thirds, MSNBC is highlighting this in their lower thirds. How do they compare and contrast? Okay. The vision, and this is short, but what we really want to do is take our corpus, take all the metadata we're building on top of it. We are, as a collective, the world is building on top of this corpus, and distribute it more effectively. Make it easier for somebody who's building a tool or a journalist who wants to tell a story to know what's happening on TV and what is all the metadata associated with what's happening on TV. We don't have a great API for finding the stuff that we're already, like the political ad data, you can download a giant CSV. This Face-O-Matic thing, no API whatsoever, it's just Slack right now. But I'd really like to use sockets to basically be pushing stuff out in real time. So when we find Trump on a program, everyone who's listening gets an alert immediately and they can do whatever they want with that. And then likewise, as an archive, we want you to be able to say who was shown on TV last month, right? We want you to be able to also look historically. The big thing that this is not an announcement and it's totally in the works, but I want to hear people's feedback, is this idea of a digital library branch. So we are a library. We don't necessarily deal in rights. We're dealing with all this awesome content that we're graciously allowed to archive. We can't let people just download it. It's not ours. So but we do want to allow researchers who are developing using artificial intelligence or using algorithms to extract data from video, we want them to be able to experiment with our stuff. So we're going to be hopefully setting up some super compute cluster, basically leveraging big boxes with lots of storage and letting specific people in to this walled digital library branch, so they can't necessarily take the data, but they can work with the data. So if anybody has any interest in being an early stakeholder in that conversation, please reach out to me. And again, the vision really is to basically make it possible. So as people are developing new algorithms, maybe it's dumb, maybe it's like the algorithm that tells you when somebody's wearing glasses on the screen, right? In my mind, that could be a signal someday that unlocks, perfect speaker identification, right? All of these different signals, why not be able to store them and associate them with moments in TV? So that's my talk. Again, Dan Schultz, reach out to me. There's my email, and I'm Slifty on Twitter. Thank you so much. I don't know, do we have time for questions or?
If there are.
Okay. Yes.
So for the services that you're running on your television content right now,
Mm-hmm.
I'm an archivist at a television organization, but we just have a general user account. Is there a way to kind of opt television submissions into that? Because we are able to provide video and captioning, but if I understand correctly, it's you guys are selecting what content you're uploading.
So you're saying in terms of, is there a way to basically add more data to the archive and have it run through these processes? Is that what you're asking?
We upload the captioning data to the video, but
Mm-hmm.
there's it's the standard Internet Archive interface.
Right.
There's not the kind of transcription search or the segmentation.
Got it. So basically, how can you add stuff to the TV archive instead of just the general archive? Yeah, good question. That is usually, we would reach out to me basically, and we can talk about how to streamline and pipeline that process. There's no, I don't believe there's a way for anybody to just say, hey, here's a video, put it in the TV archive. Just because the TV archive right now it's a pretty structured, hey, we know these are the networks that you can search against, these are the programs, and it has all that, by the way. It has the program names, it has the descriptions and things like that. So we should talk, though, because there is interest in expanding that corpus. There are channels we don't have as well in terms of a more real-time hey, we want to continue to, like, Russia Today sure might be a nice thing to be archiving at this point in history. So I don't know if that answers your question, but the short answer is talk to me directly. Yeah. Yeah. Anything else? Cool. Well, thanks. Find me. I'm over here.